Hello. In this video, I want to discuss the installation and use of a powerful application of Excel called data analysis. There are several applications available in Excel that have to be installed. The installation of these apps is done while Excel is running. Data analysis is one of those applications. To install data analysis, we proceed as follows. In the menu bar at the top, let's click on the Data Ribbon tab. You can see over on the right there is a box, an empty box. When data analysis is installed, you'll see a button for it appearing in the empty box. Okay, we're going to go over to File, click on File, and click on Options. A new box appears. In the column at the right, click on Add-ins. Then in this midsection, click on Analysis Tool Pack. You'll see it appearing at the bottom at the line Add-in. At the very bottom, click Go. A new box appears. Check the box Analysis Tool Pack, and then click OK. And there you have it. Appearing in the upper right of the data ribbon is our data analysis. Okay. Now, we're going to show the use of it. We're going to use it to perform a calculation that we did in the last class. So what we're going to do is to load up a file. It's called Demo, comparing means of two data sets, variances unequal. And this file should be now available in Moodle. So let's just double click on that. The spreadsheet opens up. Right. These are data we had seen and discussed before. These are the data that were obtained by Lord Rayleigh that led ultimately to the discovery of the element argon. There are mass values, mass measurements for two gas samples, set 1 and set 2. Set 1 are several measured masses for a sample of air in which the oxygen was completely removed chemically. The mass values for set 2 is pure nitrogen that was chemically prepared in the laboratory. Both samples are of equal volume and at equal pressure. And these values are the mass in grams. Now, when we examine these two sets of data, the calculated means, shown here, we carried out an F-test, and that was with respect to the standard deviation, shown here. And the F-test, well, let's see, we use the formula to calculate that. That's the ratio of the variance for set 1 divided by the variance for set 2. And this is the value that we came up with, 93.48. The F tab value, the F from the table, we got by using a built-in Excel function. And the value came out to 4.2. What one does is compare the calculated value of F with the table value. You can clearly see that the calculated value of F is greater than the F tab value. That tells us that the standard deviations for set 1 and set 2 are significantly different. To compare the means, what we have to do is run what we call t-test2. Now, if you do it out by hand, there's a number of kind of complicated equations. But nicely in Excel, we can do that more easily. Specifically, we're going to use the app data analysis. All right, so here we go. We're going to click on the data tab, click on the data analysis button, double click on it. All right, the box opens up. What we want to do is scroll down to the line that says t-test, two sample assuming unequal variances. Then click OK. All right. Now basically we're going to enter the mass values of set 1 and set 2 in these two boxes. The first box called variable 1 range. To do that, we'll type in the cell for the first data entry, that's B5, colon, and then the value for the last mass entry value, that's B11. So we'll type in B5 colon B11. All right, and we'll do the same thing for the set 2 mass values. We'll first enter the cell that has the first data entry, the 2.3, that cell C5. Colon, and then the cell reference for the last mass entry, which is C12. All right. Next we come to a box that's labeled hypothesized mean difference. Basically, we're making the hypothesis, the assumption that the means for sets 1 and 2 are not different. And so we'll enter 0. Now the alpha box basically is where we enter the confidence level that we want. The value 0.05, well, which is the default value, means that we're going to work at a 95% confidence level. The next thing that we do is to click on the output range option button, and then we click the cell reference where we want our data to be displayed. Now you can click any cell that you want, but let's click the cell E16 because that will correspond to the Excel data we examined in a previous class. So we just type in E16 and then we'll click OK. It will take a few moments for the calculation to complete. And there we are. Okay, it looks like it has worked. We have variable 1, variable 2. This corresponds to data set 1, data set 2. Those are the computed mean values for set 1 and set 2 respectively. These are the computed variance values for set 1, set 2. Remember, variance is the square of the standard deviation. Here we have the number of observations for set 1 and the number of observations for set 2. And this is interesting. This is the degrees of freedom. It comes out to 7. If you remember that doing t-test number 2, we have to use a special formula for calculating the degrees of freedom. It wouldn't be obvious at all what it is, and interestingly, it's coming out to the value 7 here. Now the calculated value of t is displayed here in what the label is t stat. That's the computed value of t. Now the table value of t, is what we want here, is labeled t critical two tail. We'll have more to say about the meaning of one tail and two tail. That value is 2.36. All right, to see if the means are significantly different, we compare the value of t calculated to the t table, and you can clearly see that t calculated is greater, far greater than the t tabulated value. And this tells us that indeed the means for the two sets of data are significantly different. The means of the two data sets are statistically significantly different.